To prove or verify this identity, it's up to you which side you want to start with. What jumps out to me is that the left-hand side looks more complicated to my eye than the right-hand side. And also what I see in the numerator here is the difference of two squares, which to me jumps out as, hey, let's factor those and see what we can do with that. So I'm going to start with the left-hand side, and I'm going to rewrite it. Sine to the fourth t minus cosine to the fourth t over sine squared t cosine squared t. And I build in time on the test for you to be able to write this out. There's an expectation that you're going to write it out, so I build in the time for that. When I factor the difference of two squares in the numerator, I get sine squared t minus cosine squared t times sine squared t plus cosine squared t. I still write in my denominator sine squared t cosine squared t. And then, yippee, this sine squared t plus cosine squared t, this is just equal to 1 by the Pythagorean identity. So what I have is sine squared t minus cosine squared t all over sine squared t cosine squared t. Now, what can I do with this? Well, what I recognize is that I have a sine squared t here and a sine squared t down there, and a cosine squared and a cosine squared here. What you don't want to do is just start canceling things out, because you cannot cancel terms. You can only cancel out factors, which means things being multiplied by each other. So what I want to do on this, I'm going to split this fraction up. And you can always split a fraction up if there are terms in the numerator. You can split it up over the numerator. You can't split up over terms in a denominator. But I'm going to rewrite this as sine squared t over sine squared t cosine squared t minus cosine squared t over sine squared t cosine squared t. Now, one of the things that goes through my head while I'm working these problems is I keep looking back at the side that I'm working towards. And when I look at it, I think, well, what else could this be? Well, secant squared is 1 over cosine squared, and cosecant squared is 1 over sine squared. So I'm trying to aim towards something like that, which is what's guiding my decisions along the way, and also why you have to practice these on your own. Because if what you're going to do, you're going to see me work this without running around in circles. But what you're going to do for a while is just run around in circles. You're going to try a path and it's not going to work. You're going to dead end, and you're going to back up and try another path and it's going to dead end and it's not going to work. And you're going to do this several times. And after you practice it enough, you start going, hey, I'm looking ahead and I think I see some dead ends, so I'm not going to go there. I have enough experience from this that I can see those dead ends in advance. Not always, but most of the time. So I look at the problem and I think, what am I working towards? How can I turn this stuff into what I'm working towards? And that way I can plan out steps in advance. What I see here now in this fraction is that I have a sine squared in the numerator and a sine squared in the denominator. That's a factor. So I can cancel these guys out to 1, and be sure to write the 1's in. Don't just cross them out. They don't disappear. They turn into 1. And I get the same thing here. Cosine squared goes into cosine squared, so it leaves 1 behind. Now I'm going to rewrite it up here, and notice I'm continuing to connect my steps with equal signs. We want a smooth path from where we started to where we end, and they're all connected with equal signs along the way. And I look for that. If you don't connect your work with equal signs, I'm thinking that you don't know that they are equal. So let me rewrite this now. I get an equals. 1 over cosine squared t minus 1 over sine squared t, which I know is secant squared t minus cosecant squared t, and that's what we set out to get. That's our right-hand side. Always show this last step. Don't leave it there and say I'm done, because you're not done. You have to show that you can get it to the last step. Yes, I know that you can go to the right step, but I know all these other steps too. You have to show me that you know what this step is. So always take it to the last step and show that it's equal to the side that you set up to get. Pay attention to that level of detail, that level of showing the steps, that level of notation. There's an expectation that you're learning this, and you need to do it this way and not just cut corners.